In this lesson, we're going to focus on Newton's third law of motion. For every action force, there is an equal and opposite reaction force. Now let's use an example to illustrate this. So imagine if you're a skater, skating on ice, and you have a ball in your hand. If you throw the ball to the right, what's going to happen to you? Are you going to stay in the exact same position, or are you going to move somewhere? Just imagine it. Imagine if you are skating and you throw the ball to the right. What do you think is going to happen to you? If you throw the ball to the right, you're going to feel a force that pushes you back towards the left. And that's the basic idea behind Newton's third law of motion. So if you push the ball with a force of 100 newtons east, you're going to feel the exact same force, but in the opposite direction. That is, going west. So just make sure you understand that. The magnitude of the two forces have to be the same. The only difference is the direction. The direction is always opposite to each other. Now let's look at another example. Imagine if you're on a boat in the water. And you have a ball in your hand. Now let's say you want to move in this direction. Where should you throw the ball? Should you throw it to the left or to the right if you want to move to the right? If you want to move to the right, take the ball and throw it in the opposite direction. If you throw the ball to the left, you and the boat are both going to move to the right. Now, because the mass of you and the boat is much greater than the ball, you're not going to move very far. The acceleration that you experience will be very, very small. Now the ball, which has less mass, will feel a greater acceleration. So with the same force, if you decrease the mass, the acceleration increases. And if you increase the mass, the acceleration decreases. So if you throw the ball with a force of 200 newtons, you're going to feel a force of 200 newtons in the opposite direction. However, because the mass is different, the acceleration will be different. The ball, which is much lighter than you, will have a larger acceleration. You, combined with the boat, because you have a much larger mass, the acceleration you experience is smaller. So the boat and you won't feel like you won't move much because of the low acceleration. Now, imagine if you're an astronaut in space and you're floating in space. There's no other planets around you. It's just empty. And you have a ball in your hand. Now, let's say if you want to travel in the upward direction, maybe towards a planet that's pretty far away, but you want to head in that direction. So if you want to travel up, where should you throw the ball? In space or anywhere, if you want to throw something to move in a certain direction, throw that object in the opposite direction. So if you throw the ball down, you're going to feel a force that's going to accelerate you in the upward direction. So the harder you throw that ball, the greater the force will be that's going to accelerate you upward. Now this example can also be applied to a rocket. When a rocket launches towards outer space, it expels the gas. And so as the gas is being expelled downward, an upward force is created based on Newton's third law. And that upward force causes the rocket to accelerate upward. So now you know how rockets work. The same principle can be applied to a balloon. Imagine if you have a balloon and if you pop a hole, and let's say the hole's right here. Gas is going to come out of the balloon. And wherever the gas is coming out from, the balloon is going to fly in the other direction. And perhaps you've seen that. Or even if you blow a balloon, if you blow air into it without tying it, once you let go of it, once that air is released, you'll see that the balloon is going to fly in the other direction. And so that's how you can use gas to propel an object forward. Wherever the gas comes out, the object is going to be propelled in the opposite direction. Now, the last example that illustrates Newton's third law is the force of gravity. So let's say this is planet Earth. And over here, we have the moon. How does gravity work between these two objects? Gravity is a force that attracts objects together. It pulls them together. So the moon pulls the Earth toward itself, and the Earth pulls the moon toward itself. But because the moon is traveling in a circular direction, it never falls towards the Earth. The moon wants to fly out towards outer space, but because the force and velocity vectors are perpendicular, the moon instead travels in a circle. It orbits the Earth. But nevertheless, the force of gravity is an attractive force. It brings matter together. Now, these two forces, they are equal in magnitude but opposite in direction, as you can see. One is towards the right, the other is towards the left. Now, which object experiences a greater acceleration? Is it the Earth or the moon? Now, the Earth has more mass than the moon. So therefore, the acceleration will be less. The moon has less mass than the Earth, so it's going to have a higher acceleration. And so just keep that in mind. The object that has more mass has a lower acceleration, and the object with less mass will experience a greater acceleration. Let's work on an example problem that will illustrate Newton's third law as it relates to forces, mass, and acceleration. Lucy, who has a mass of 60 kilograms, pushes against Sarah, who has a mass of 90 kilograms. Now Lucy pushes against her with a force of 540 newtons directed east. So let me draw a picture. So let's say that's Lucy. And let's say this is Sarah. So Lucy is smaller than Sarah. Now Lucy pushes against Sarah with a force of 540 newtons directed east. So part A, what force does Sarah exert on Lucy? Now Sarah is going to push against Lucy in the opposite direction, that is towards the west, because according to Newton's third law, the two forces must be opposite in direction. And also the magnitude of both forces have to be the same. So Sarah is going to push against Lucy with the same force of 540 newtons directed west, while Lucy pushes against Sarah with 540 newtons directed east. So what you need to take from this is that the forces, they have to be the same. They have to have the same magnitude, but they must be opposite in direction. Now Lucy has a mass of 60 kilograms, and Sarah has a mass of 90 kilograms. Who is going to experience the greater acceleration? Because Sarah's mass is larger, her acceleration will be lower than Lucy. Lucy is lighter, so she's going to experience the great acceleration. And so to find acceleration, you can use this formula, F is equal to ma. Solving for A is going to be the force divided by the mass. So for Lucy, it's going to be a force of 540 newtons divided by 60 kilograms. So if you cancel the 0, it's 54 divided by 6, which is 9. So Lucy will experience an acceleration of 9 meters per second squared. Now what about Sarah? She feels the same force of 540 newtons, but her mass is 90. So 54 divided by 9 is 6. So Sarah experiences an acceleration of 6 meters per second squared. As we can see, the person with the greater mass will experience a lower acceleration. The person who's lighter experiences a large acceleration. But the force exerted on both individuals will be the same according to Newton's third law. So that's it for this video. Thanks for watching.